All right, let's dive into a tool that has kind of quietly completely changed the game for how massive companies manage their digital worlds. We're talking about SaltStack, and really how it brings actual intelligence to infrastructure automation. Let's get into it.
Seriously, just think about that for a second. How on earth do you patch or configure or even just check the status of 10,000 servers, maybe spread all over the globe, all at the exact same time? One command, one single point of control. It sounds like something out of a sci-fi movie, but you know what? This is the very real challenge of modern IT.
You see, the old way of doing things, logging into each machine one by one, running scripts by hand, that just doesn't fly anymore. As your infrastructure balloons from maybe a few servers to thousands, that manual approach becomes impossibly slow. It's just begging for errors, and it's completely, totally unsustainable. You need a better way.
And that really brings us to the heart of the problem with modern infrastructure. Your DevOps teams, your IT teams, they're under this constant pressure to ship software faster, to scale up or down in minutes, and somehow maintain perfect reliability. It's this nonstop battle to take the potential chaos of thousands of systems and wrestle it into a state of perfect control.
And this is exactly where SaltStack comes into the picture. It's not just another automation tool. It's a fundamentally different way of thinking about the problem, built from the ground up for the kind of speed and scale that modern infrastructure absolutely demands.
So what is it really? Well, SaltStack, or just Salt as most people call it, is an open-source platform that was created by Thomas Hatch way back in 2011. It's built to do three things really, really well. Manage your system configurations, execute commands remotely on tens of thousands of machines at once, and, this is the most important part, enable automation that actually reacts to events in real time.
You gotta understand, Salt was built on four key ideas. First, speed. Everything happens at millisecond scale. It's incredibly fast. Second, flexibility. Salt doesn't care if you're on AWS, in your own data center, running Linux or Windows. It just works. Third, security. All the communication is encrypted right out of the box. And finally, intelligence. Now this is the real game changer we're going to explore, where the system itself can process events and make decisions on its own. Okay, so to understand how Salt actually pulls all this off, it really helps to think of it as the central nervous system for your entire infrastructure. It's an architecture that's literally designed for instant communication and reflexes.
The core pieces map perfectly to this analogy. So you've got the Salt master, that's the brain, it's sending out the commands. Then you have the minions. These are the little agents running on all your servers, and they act as the nerve endings that receive and carry out those commands. The communication between them happens on what's called the event bus, a super high-speed messaging system that uses something called 0MQ, which is the secret sauce for its incredible speed. Think of the event bus like the body's reflexes. And finally, you have states. These are just YAML files that act as the blueprint for what each and every server is supposed to look like.
Now here's a concept in Salt it is absolutely critical to understand. Grains versus pillars. Think of it this way. Grains are facts about a minion that it reports back to the master. Things like its operating system or how much memory it has. It's all about discovery. Pillars, on the other hand, are secure pieces of data that the master sends down to a minion, like API keys, passwords, or specific user roles. It's all about targeted configuration. So one is what the system is, and the other is what the system should know.
Now what's really interesting about this slide is what you're looking at. This is a Salt state. This isn't some complex script telling a server how to do something step by step. No, it's what we call a declarative blueprint. It just describes the end result you want. So this state file just says, hey, Apache needs to be installed and the Apache service needs to be running. Salt then figures out all the rest, making sure every server matches this exact blueprint. This is the power of infrastructure as code.
Okay, everything we've talked about so far is cool. But this is the feature that truly sets SaltStack apart. We're about to move beyond just giving commands and into a world where our infrastructure can actually start to think for itself. We're going from being reactive to being proactive.
This right here is the key idea. Most automation tools, they're all about pushing commands out. And look, Salt does that exceptionally well. But its real magic is that it also listens. The minions are constantly aware of what's happening on their system, and they can send signals back to the master. This creates an incredible feedback loop.
So, how does this actually work? Let's take a classic example. A web server crashes. Okay, step one. A little component on the minion called a beacon detects this failure.
Step 2, it immediately signals this by firing an event onto that high-speed event bus. Step 3, a system on the master called a reactor, which has been listening for exactly this kind of event, reacts and catches it. And finally, Step 4, the reactor automatically triggers a command to heal the system by restarting the service. The whole thing happens in milliseconds with zero human intervention. This is what self-healing infrastructure actually looks like.
That sounds amazing in theory, right? But let's take a look at how this kind of speed and intelligence is actually being used in the real world by some of the biggest names in tech.
I mean, you've got companies like LinkedIn, eBay, Adobe. They've all relied on SaltStack to manage their massive global infrastructures. Because when you're operating at that kind of scale, with services that have to be available 24/7, the ability to command and react across tens of thousands of machines isn't a luxury, it's an absolute necessity.
And if you compare SaltStack to the other big players in this space, tools like Ansible, Puppet, and Chef, you can see they all have their strengths. But just look at that last row, event-driven capabilities. This is Salt's unique defining advantage. While you can kind of configure the other tools to react to events, Salt has this capability built into its very core, which makes it natively faster and just way more powerful for building these responsive, intelligent systems.
So, the crucial point, the main takeaway is this. SaltStack isn't just a tool for one single job. It brings together configuration management, multi-step orchestration, and real-time event-driven automation all into one cohesive, incredibly fast platform. It's a unified solution for these huge modern infrastructure challenges.
And that really leads us to the ultimate goal here. With a tool like SaltStack, we can build infrastructure that doesn't just sit there waiting for us to type in instructions. We can build systems that are aware, that can react to problems, and can even heal themselves before a human ever knows there was an issue in the first place.
So, I'll just leave you with this question to chew on. In a world that demands more speed, more scale, and more resilience every single day, is your infrastructure ready to move beyond just following orders and maybe start thinking for itself? Thanks for watching.